Welcome to this video on load calculation for duplex using the optional method. We're also going to figure out the minimum overcurrent protection device. Okay, so first I'm going to get into a summary / page layout. It's going to show you a summary of all the rules and directions to figure out this load calculation. And then it's also going to, at the same time, double as a page layout. So you're going to see how to fill out your page. That'll be the first half of the video, which will not include the actual numbers, and it'll just be a direction of how to fill it in. And then in the second half of the video, I'm going to show you an actual example, which is going to ask us a question involving solving for the duplex using the optional method. And I'm going to walk through and solve it with you. Make sure to check out my multifamily optional load calculation video before this, because you're going to want to know all the rules for multifamily using the optional method before we get into the duplex here. This is going to make a lot more sense once you go through both of those videos and you solve both of the questions. You also see that in this series, I have each of the videos part 1, part 2, part 3, and you'll see that the multifamily video for optional method comes before the optional method for duplex. So that's why I did it in this order. Okay, before I get into the page layout and summary, let's actually find out where to find these rules in the code book. We want to go to article 220.80, which is the beginning of part 4, for the load calculation, which is using the optional method. We want to be aware with the fact that article 220.82 is for dwelling unit, and that is not plural, it's a single unit. Okay, so you see article 220.82, the subsection A, B, and C, those only apply to one single family dwelling. Okay, so that's why if you watch the residential load calculation video using the optional method, of course, I started off with the single family there for the first video, and you'll see I explain everything, and we're using the rules from article 220.82. But in fact, if we flipped over to the next page, and we go over to article 220.84, we see multifamily dwelling. And in here, it states that if we have 3 or more dwelling units of a multifamily dwelling, then it is permissible to calculate this using table 220.84. Now you might say, well, this is saying multifamily, and it's also saying 3 or more. Now this is why I recommend to watch the multifamily optional method video before this, because this is where things get confusing. If you watch that video or have done a multifamily optional method load calculation before, then you already know how to use table 220.84. But here we have a duplex, so we only have 2 units. Okay, so to figure out what to do, we need to go to article 220.85, where it says 2 dwelling units. And this is worded extremely weird. You can read it for yourself, but to sum it up, what it's actually saying, to sort of decipher what it's actually saying here, it's saying if you have 2 dwelling units using the optional method, then it is permitted, which means you're going to use 3 identical units calculated under article 220.84. Okay, so to further decipher what that means that if you have a duplex using the optional method, you're going to count that as 3 units, okay, just simple enough. Don't overthink it. And you're going to use article 220.84, which again, I just read, that tells us to use table 220.84, which we already know how to use from doing the multifamily optional method load calculation. So we already know how to do that. And now we know that if we have duplex, we're counting that as 3 units, but treating it like it's a 3-unit multifamily. Okay, so that's probably the best way to explain it. That's why I have ×3 in parentheses here. If you follow my videos by now, you'll see that when I get to duplex and multifamily, I do in parentheses the amount of units we're working with, okay? And this is because every time that we have a certain number, for example, we have 3 appliances with their ratings. If we have a duplex with the standard method, we're going to multiply everything by 2. So if we have the 3 appliances, we multiply that by 2, we now have 6 appliances, and all their ratings also get multiplied by 2. And this is a very important step in the load calculations, because you need to multiply by the amount of units you have, aka the amount of appliances or the amount of load that you're going to have. The difference here is that in the optional method, it's sort of a boiled down version compared to the standard method. There's a lot less steps, there's a lot less demand factors and weird exact rules. We're basically adding everything together, and then we're doing one demand factor at the very end. It makes it a lot quicker and simpler, and I would consider it more of like an estimate compared to the standard method, you're getting a little closer to figuring out certain particular things. Sometimes when you get the same question and you do the standard versus optional method, the answers are pretty similar, but sometimes they can be a little bit further apart. So it is a different method, but most of the time you do get an answer that is pretty similar depending on which method that you use. Okay, so now we know where to find the rules in the codebook and we know what the rules are. So to sum it up, when we have a duplex using the optional method, we're going to count it as 3 units, and because of that, we're going to be using table 220.84, which has the demand factors for multifamily, and that's where we're going to look at where it says 3 to 5 units. We're going to consider it 3 units, and we're going to get that 45% demand factor. I'm going to explain all this in the actual video, but we really need to pay attention and just think right now before we get into anything that unlike a duplex for standard method where we get everything, we multiply it by 2, we're now going to get everything and multiply it by 3. Okay, and it's going to make a lot more sense if I just explain this as I go, but I just want to ingrain that in your brain before I get into everything, because we got to keep reminding ourselves duplex optional equals 3. Duplex standard equals 2. Okay, so it's pretty simple, but you just have to get used to it. Okay, so now getting into the rules and everything. Of course, we're always getting the square foot of the house and we're multiplying it by 3 volt amps. We have 3 volt amps per square foot, no matter if we're using the optional or standard method. We always do this. When we multiply our square feet by 3 volt amps, we're of course going to get a number. I'm just going to call it n for a variable. And then at all times, unless it mentions an exception, we're going to add 4,500 to that number there. This is of course for the 2 small appliance branch circuits plus the 1 laundry circuit. The exception you can find in my residential load calculation video part 3, explained more in depth, and basically summed up somewhere in the code book. It will tell you that there's an exception to not include your laundry in this calculation. So at that point, you'd still have your 2 small appliance branch circuits and you'd have 3,000 volt amps added to this, but you would not have the additional 1,500 volt amps for the laundry circuit. This is only if they mention to not include the laundry load in your calculation. When we add that number that we got from our square foot times 3 volt amps to the 4,500, of course, we're going to get another number, okay, the total of those two. And then from there, in the standard method, we normally do demand factors. Here in the optional method, we're not doing any demand factors until the very end, and that's where we use that table. Okay, but it's very important to remember that we're multiplying everything by 3. So we still have to remember that part of it. And then after we multiply that by 3, we get our actual number, which is going to be our general lighting load number. Imagine I have a number here, and I'm going to circle that number, and then I'm going to label it like you see GLL, so I can quickly look at this section, and I can see my total number for this section, and what it is. The GLL, it's the general lighting load section. From here, I draw a line that's very easy to see that's going to separate the section and keep it isolated on its own. We see I did the times 3 in parentheses here. This is important because I only do it in parentheses when I'm doing the amount of units. If I have something in the question, for example, 2 of a certain appliance in each unit, then I'm going to multiply it by 2 without parentheses. So I'm going to look back and see that in the math. And then if I also have 3 units here, or I'm doing a duplex using optional, I'm going to multiply it by 3, and I'm always going to put, when I'm doing the amount of units, in parentheses. So I'm going to glance at this section and see that in fact I multiplied this number that I got by the amount of units that I have. And then when we actually fill this in with real numbers and everything, it's going to help us a lot when we look back at everything and make sure that we actually did everything correctly and we multiplied by the correct amount of units, so we make sure we get the correct answer. Now we're finished with that section. After the general lighting load section, we get into the appliance section. It's kind of a lot to write appliance out every single time, so I just write APP. It's good to know that these are going to be rated at 100%, just like everything else, because we're doing the optional method. In other words, there's no demand factors, just like we saw with the above section that we just did. So everything is rated at 100%, but we need to realize that no matter how many appliances we have and their ratings need to get multiplied by the amount of units we have And here we're multiplying everything by 3. And by the end of this video, I'll say that enough times so you'll remember and you won't forget that duplex using the optional method is times 3. Of course, we're going to get a total number there, and then we're going to want to circle that total number and label it. And again, I'm just going to label it APP, and that is for appliances. Okay, now we're going to get into the next section. As you can see, this is a lot quicker than the standard method, and that's the whole point here for the optional method, is that it's going to go a lot quicker. There's a lot less steps. The next section, we have HARD, where I draw H and A pretty close to each other for heat and AC, and then I draw R with a space and D to where the R and D are in their own little space here. Okay, it's good to know that everything's going to be rated at 100%. Okay, so first starting with the heat and the AC, we're not going to have demand factors for either the heat or the AC, and that is because our demand factors for the optional method actually come from Article 220.82, which is for the single family dwelling unit. In fact, when we get to Article 220.84 for multifamily dwellings, we don't have anything that's telling us to have any derating factors or demand factors for our heating or AC. Because of this, we're going to get everything at 100%, but of course, just like always, we need to pick the bigger one, okay? So let's say the AC is bigger. We're going to pick the AC, the number that we have for the AC, and we're going to disregard the number that we have for the heat, okay? And you probably thought I was going to say this, and that's that we don't only need to have everything at 100%, but we need to multiply everything by the amount of units that we have regardless. Okay, of course, that's going to give us a total number, and I'm going to circle that total number, and then I'm going to label it here AC. We get into the next section. We have the range. We're going to get a nameplate rating. If it doesn't tell us the nameplate rating, then we're going to go into table 220.55, and we're going to see column C. We're going to rate it as one appliance at 8 kilowatts, and then we're going to multiply it by 3 units and get 24 kilowatts for our rating. So in other words, if we're using the optional method and it doesn't say a nameplate rating for range, we're going to have 24 kilowatts. Using the standard method, we're going to again use table 220.55 column C, but we're going to count it as 2 appliances at 11 kilowatts. This is one of the things where we can see using the optional method gives us quite a big difference in the number, but it's good to know that it's pretty rare to not have a nameplate rating for your range. It's more likely that you are going to get a nameplate rating, and you're going to have that at 100% just like everything else, and of course you're going to need to multiply that by the amount of units you're working with, and oddly enough here, of course, we're using times 3. Okay, so we're going to multiply everything by 3. We're going to get that total answer, and when we have our total answer, we're going to circle it nice and bold. That's going to be easy to see, and we're going to label it range. Okay, we get into the next section, we have dryer. If we do not have a nameplate rating for the dryer, then Article 220.54 tells us we need a minimum of 5 kilowatts or the nameplate rating, whichever one is greater. And when we pick which one is greater, of course, it's going to be still rated at 100%, and then we're going to multiply by the amount of units that we have. When we get that total number, we're going to circle it nice and bold, and we're going to label it with the associated thing that we're working with. Here we have dryer, so we're going to label it dryer. Okay, now you're just going to get all these numbers, and you're going to add them together. Okay, and now normally these are going to be filled with numbers like I was explaining, so pretend these all have the total number in each section. We're going to add these all together. When we add everything together, that's going to give us our total watts, okay, but from there, we need to apply our actual demand factors that we're going to find in table 220.84. Of course, with the duplex for optional method, we're always using times 3 or 3 units. We're counting it as 3 units. So we are looking at 3 to 5 units here at table 220.84, and it tells us a 45% demand factor. So that total watts that we have, we're going to use a demand factor, and that's always going to be 45% here when we're dealing with 3 units with the optional method. From there, we're going to have what is known as the total demanded load for this duplex dwelling, and this is going to be in watts. From here, I normally box this since I circle everything, and then I know that that is my total watts after doing the demand factors. and we're going to want to divide this by 240 volts from here. This is because watts is also going to be thought of as volt amps here in the load calculations, because we're not thinking about power factors or anything. So we're not thinking about efficiency ratios or anything. We're just thinking about the plain numbers. So we could think about this as volt amps. So we're going to divide by our volts, and that's going to give us our amps. But we need to stop right there, because that may not be our answer, because a lot of times we're not going to have a standard breaker rating. To find the standard rating for our overcurrent protection device, or in other words, our circuit breaker, we want to go to table 240.6a. And from here we see a bunch of numbers, and if we are in the middle of any of these numbers, then we are going to size up to the next size if it is 800 amps or less. If the next size is over 800 amps, then we're going to actually size down to the lower size if we're in the middle of two numbers. Of course, if we land exactly on one of the numbers here in table 240.6a, then we're just going to pick one of those numbers for our answer. The reason why we're doing 800 amps or less sizing up and over 800 amps sizing down is because Article 240.4 Section B tells us to do that. So you could read that and highlight that for yourself. I do explain that in the previous videos. So that's why it's good to also watch the follow-up videos that lead up to this video, because I'm trying to summarize some of the things that I already explained in my other videos, sometimes mention them in multiple videos by now. And after finding that number in table 240.6a, then we're actually going to know our amp rating for our overcurrent protection device, or in other words, our circuit breaker, which is our circuit breaker for our service. So it could also be called our service rating. So as we see, that's an amps for the overcurrent protection device. But then if we just wanted to know the total demanded load for this duplex dwelling, then we would have that number here in watts. So that's why I squared both of these, because these are both final answers. One's in watts. I divide by 240 because we have the A phase and the B phase in our panels, which give us a 240 volt potential system. Oftentimes we're just using one leg and we're using 120 volts, but as we know, some of our appliances use 240 volts. So we divide by 240 volts, not by 120. Just got to remind yourself of that if you're new to this. And that is all that we do. Now we figured out how to solve for the overcurrent protection device. Of course, there's no numbers here, but this is going to simplify everything. So then when I actually get into the question, which is going to be next, I'm going to fill out my page the same way, in the same order, and do the same rules and everything. And we're going to be able to see these little things like ×3 in every section, and then our number circled and labeled in each section. It'll be easy to see. If we want to double check things, we'll be able to double check it easy. If we want to double check at the end our final answer, we can add that together a few different times. And following this method, separating it in sections, clearly labeling certain important things, and also taking your time and not rushing is a guaranteed way to not mess up doing this. You got to make sure to focus and stay calm, but it's not going to be easy to do that if you're not familiar with this and if you don't have a lot of experience doing this. If you have a bunch of experience doing this and you've done this a bunch of times, you're going to be super comfortable doing this. You're going to crack your knuckles and think no problem. But if you just want to do this a few times and think, oh, it's simple, I saw a YouTube video on it, it's not that hard, and you want to go and maybe pass your test or whatever, then, I'm not saying that's not going to happen, but you may not actually remember any of this stuff. You may not actually understand exactly how to do this when it gets onto the field, when you get a job from someone and they tell you, hey, I have these units and I want to know the amount of wattage that I'm going to have for that. And if you're the boss and you're going to have to go, oh yeah, I'll try to maybe figure that out later or something. And if you can't confidently tell the builder or the contractor there that, oh yeah, I just know that that's going to be this amount of watts, or I could, get a stud and I could draw on maybe even some plywood or something and just figure out the answer to the wattage of the house, so you could confidently tell them no problem. Okay, you want to be confident, and you don't want to be sitting there not being able to do certain things that it takes to get the job done. Why would you want to do that in the first place? So this isn't just for passing a test like grade school or something and getting an A+. This is literally training you for real life. When a customer comes your way and they tell you they have a certain thing and you can help them out with that. Okay, because that's simple business. When people need something and you can offer it to them, they're going to pay you for it. If you're not into business and running a business and you want to work for someone and make good money, of course, that's another option here with electrical. It doesn't matter. If you can tell your boss that you can do load calculation and stuff, you're either going to get a better position or you're going to get a raise or taken more seriously, and you're probably going to end up getting paid more. So you got to take this stuff seriously, and you got to take yourself seriously. This is serious stuff. This isn't just easy, simple stuff. And once it breaks down to it, it seems pretty easy once you've done it enough. But we can all probably remember after doing this our first time, it seemed almost like a complete foreign language, looking at the code book and then also looking at the load calculation and stuff, okay? Okay, so now let's get into the question. It's good to know that if you're taking a test, a lot of times they like to be vague and not really tell you a lot of information or tell you things at awkward times. So a lot of times in your practice test, they're going to ask you things like, using the optional method, do this load calculation, and it's going to be very straightforward. But a lot of times then you're going to go in your test and it's going to say, solve this load calculation for this duplex unit, and they're going to tell you all these random numbers, and then they're going to at the end say, use the optional method. So if you already started writing a bunch of stuff down and getting ready and solving things along the way, then you get to the very end, you see optional method, you will think, oh, I just, didn't see that yet. So you need to probably make sure to read the question once first before you write anything down. But not only that, but be aware that they might just ask things in awkward ways. So you got to be on your tippy toes, and you got to probably read what they say a few times and really make sure that you got what they were asking you. Okay, so I'm going to ask it kind of like they would on the test, not exactly, but just in a similar format, not extremely straightforward. I just wanted to explain that before I did it, so you didn't think, why the heck would I word it this way? Because that's what you might think if you're taking your test. Okay, so getting into it, solve the load calculation for the duplex dwelling unit supplied by a single feeder. Each dwelling is 1,600 square feet, has a 20 kilowatt heating system, a 20 kilowatt air conditioning system, a range, a dryer, a 5.5 kilowatt hot water tank, a 1.2 kilowatt dishwasher, a 1 kilowatt disposal, an attic fan at 120 volts that is at a half horsepower. Find the minimum overcurrent protection device and use the optional method. Okay, so you can see there I saved the minimum OCPD and the optional method till the very end. So if you started already writing some stuff down, you might think, oh crap, I didn't leave room for that or something. And that's what's often going to happen. They're going to ask you on the test in some weird way that might not be in the order that you're used to. Okay, now let's start writing the stuff down from the question. But first off, especially for the optional method duplex, I really want to tell myself somewhere that's going to be very clear as a reminder that I need to do everything times the 3 for the 3 units. And this is because then when I look at the end, when I double check everything, I'm going to see this and I'm going to make sure that in each section I did that. And I'm already thinking about that right now before I start filling everything in and do times 2 without thinking about it, since it's duplex or something similar to that. Okay, so we're told that we had 1,600 square feet. So I'm going to write that down. And then of course we have 3 volt amps. Pay attention, we have times 3 here, and I'm not doing it in parentheses. We're going to get that total number, and we're going to add 4,500 to it. And we know we're going to multiply that total number by 3, and we don't have any demand factors. Okay, so I already have this section set up. Before I pull out my calculator, I'm just going to move on to the next section and label everything in the next section. Of course, you don't have to write down that much, and you can just write down the 1,600 square feet if you want to. But in this case, I'm just going to set it up for myself to make it a little bit quicker. I'm going to move on to the next section. I have a hot water tank, a dishwasher, a disposal, and a fan. Pay attention to how I shortened the names of everything. And I'm just going to do this so then I can write down my numbers. Okay, so in kilowatts, we have 5.5, 1.2, and 1. And then the fan, we have a half horsepower, and we were already told 120 volts. But if we weren't told 120 volts, we would still know that we are using single phase here for dwellings, and we're using 120 volts for motors if we aren't told anything else. So we're going to have to figure out our amps to find out our wattage for that. I'm going to save that step till later. But we want to make sure that when we get our total number that we add together for appliances, that we multiply everything by 3. Of course, we don't have any demand factors here using the optional method, but we need to make sure the multiply by 3. So I'm already going to put that here in this section. so I'm not going to forget when I get into it. Okay, now I'm going to get into the next section where I have the HARD. I'm going to keep in mind the amount of space that I have here. Normally I'm going to use a piece of paper, then I'm going to have a lot more room writing vertically in the portrait style instead of having like the landscape view where I have my whiteboard set up for the screen. So no matter what situation you're in, just be aware of how much room that you have. I need to write the HARD. I need to have the math for each one of those, and then I need to have enough room to also add every number together, have a total number, and then also multiply that by my demand factor, and then also divide by 240, get my amps, maybe convert it to the actual standard breaker size. So there's a lot of stuff that I need to keep in mind here, and mainly it's that I need to have a good amount of room for each one of the steps. So first, getting into the HARD, I'm going to write the HA, and I'm going to figure out how much space I'm going to need. I know the optional method, I don't have a lot of math, so I'm just going to put my R here and my D here. I'm going to draw a separation line for those, and then I'm also going to draw another separation line over here so I have enough room to add together all my final numbers, do all the demand factor, and all that other stuff that I need to do at the end. So I know heat and AC, I had a 20 kilowatt system for both of those. So I'm just going to write that down. I have 20 kilowatts for both. And in this circumstance, when they're the same rating, it's really up to you to say which rating are you going to pick, because there's no difference. You really don't need to think about it too much. So in this case, I'm going to pick the heating. I'm going to disregard the number for the AC. But we still need to multiply every section by the amount of units that we have. So we actually end up, I always just like to write it out with 20 kilowatts times 3 for the amount of units, and we end up with 60 kilowatts, okay? And that is for the heat, okay? So I already solved that, but we saw that just basically happened as I went. It's so obvious that how can I not do that? Okay, we're going to get into the next section, the range, and we actually do not have a nameplate. So I'm just going to write no NP, and for the dryer, the same thing. We actually did not get a nameplate, no NP. So I discussed briefly what to do in the summary, but now I'm actually going to go through with it a little more in depth here. Okay, so when we don't have the nameplate rating of the range, we're going to go into table 220.55 and look at column C. The only thing here is that for the optional method duplex, we're not going to think about the number of appliances that we have, since we're multiplying everything by 3. It's kind of weird. So just think about, it's a little bit weird how we're multiplying everything by 3 and using the multifamily table. This is something that you can use to help associate with the fact that we're going to be using column C here, but what we're going to be doing is looking at column C for one appliance. Column C for one appliance tells us that we have 8 kilowatts. From there, we need to multiply that by the 3, the amount of units that we're working with here, and we're going to end up with 24 kilowatts. Okay, now this is something that you're normally not going to see, but it's something that's good to know how to do. So now we have 24 kilowatts, and that is the load for our range here, the demanded load. Again, if we had the standard method and we didn't have a nameplate, we'd still use column C for table 220.55, but we'd use 2 appliances and we would have 11 kilowatts. So we can see that's quite a big difference, because this is more than twice the amount of that, and that's why you normally will never see this. You're normally just going to see a nameplate rating, and if you do see a nameplate rating, of course, just like everything else in the optional method, you're just going to have everything at 100%. You don't have any demand factors. You don't have any tables telling you demand factors like you normally do for your standard method. Okay, now that we figured out the range, we're going to get into the dryer. Again, we don't have the nameplate rating, but we know that I went over in the summary, Article 220.54 tells us we need that 5 kilowatt minimum. So we already know that we need that 5 kilowatt minimum, and we also know that we need to multiply by 3 units here. So we are going to get 15 kilowatts as the total number for our dryer. In other words, the demanded load for the dryer for this duplex here. It's really that simple, 5 times 3. Okay, now I'm going to get into solving the other portions. We saw that these portions were so simple, I kind of just solved them as I went. I could have done that to the other sections as well, but it might get a little complicated. I'm also going to double check these sections once I finish these two. So starting from the top and going down, we have the square footage of the house, and we have 1,600 square feet. We're going to times that by 3 volt amps, and we're going to get 4,800. From there, we're going to add 4,500. From there, we're going to get 9,300. We need to multiply that by 3, and we're going to get 27,900. Of course, we want to label what this is. These are either volt, amps, or watts. It's going to be a lot simpler just to draw a W. So I'm going to draw a W, and we need to label what section this is. This is the general lighting load section, and now we know we have 27,900 watts for our general lighting load section. Remember, there's no demand factors or anything like the standard method, so it's really that simple. Okay, we're going to get into the appliance section for now, and I always like to fill in anything that is not completed yet before I get into everything. And if we look at the fan, we don't have the wattage for the fan. And for this, we're actually going to want to go into the motor tables. So we're going to go way into article 430, and we're going to go into table 430.248, which is the full load current in amps when we're using single phase motors that are alternating current. We don't want to use the table before that, which uses direct current. Okay, so we know that we're working with 120 volts, but when we look at the table here, we see 115 volts, 200 volts, 208, and 230 volts. Now, this might seem kind of weird, and you might already start thinking, well, what are you going to do to solve your answer? Are you going to multiply by 120? Are you going to multiply by 115? And if we're multiplying by 120, why would we then look at the column where it says 115? Okay, so this gets kind of weird. I don't want to have you jumping around all over the book, but for this, you kind of have to. We're going to go back into Article 220 in the very beginning, 220.5, subsection A, where it says voltages, and it tells you that we're going to use nominal voltages here for the load calculations. We see that we're only going to use the numbers 120, 240, 208, 347, 480, 277, 600, and those voltages will be used also in different combinations with each other, but you're only going to be using those. So in the table here, we see 115 volts, but we need to know when we do our load calculations, we're only using nominal voltages. So although we're going to look under the 115 volt column, we're going to use 120 volts for load calculations because that's what it tells us to do. Okay, so we're under 115 volts and we see we have a half horsepower here. Under a half horsepower, we have 9.8 amps. Remember, again, this is telling us in amps. So we have 120 times 9.8, and we get 1,176 watts, and now we know the watts for our fan. So now we're going to start from the top down so I don't mess anything up, and I'm also going to convert everything into watts because this last number here has 1,176, so it might be a little weird to turn that into kilowatts. So I'm going to have 5,500 watts here for my hot water tank, and then I'm going to add 1,200 watts for the dishwasher, 1,000 watts for the dispo, and then 1,176 watts for that fan. I'm going to get a total number of 8,876 watts. I need to multiply everything by the amount of units I'm working with, so I multiply that by 3, and I'm going to get 26,628. Of course, make sure you label everything. Label it watts, and not only label it the watts, but I also need to label the fact that this is my total number for my appliances. Okay, so I have that labeled, and I also have the general lighting load labeled, and now I can move on to the next section, which is already done, and now I can just double check it. I had the 20 kilowatt heating and the 20 kilowatt AC. I just picked either one of those since they're the same thing. I made sure to multiply by 3 so I can see that. I had 20 times 3 equals 60. Everything looks good. I had my range. I know that I went into the table and I got 8 kilowatts times 3, so I got 24. And then I have my dryer, which is 5 kilowatt minimum with no nameplate rating. I multiply the 5 times 3, I got 15 kilowatts. Okay, so I have everything, and I also have it labeled, so now I can add everything together, and then I can find the demand factor, which we already know what it is, probably because we just did that, but it's good to just open up your book and to double check before you get a little too confident and slip up somewhere. Okay, so I already basically just double checked each section, saw that I have each section filled in. You're gonna want to do stuff like this, and then you're also gonna want to, in the moment, double check everything. So when you fill in each section, make sure you fill it in one time, and you're probably gonna do it a little slower the first time, and then fill it out a second time, make sure you get the same answer, and then move on to the next section. Do it one time, do it a second time a little quicker, and make sure you get that same answer. You really got to make sure you do this. It's going to help you a lot to catch any mistakes if there are any. And then furthermore, if your section is pretty complex, you're going to want to break it up so then you don't just have everything all at once. You're probably going to want to do it halfway and then get an answer and then do the other half. And then you can double check that 2 halfway, and then maybe you double check it one time all the way through just to make sure. You're going to have a lot of time to do this normally when you're doing this, so don't rush anything. Take some time and double check things. That's why it's good to do everything in a section, so if you mess something up, it's not that big of a deal, and you don't have to redo something major. You just have to redo one section or something. Okay, so now we're going to add everything together from the top down. We're going to start with the general lighting load. We have 27,900. We're going to add the appliances, which is 26,628. From there, we're going to add the heating, which is 60,000. From there, we're going to add the range, which is 24,000. And then we're going to add the dryer, which is 15,000. I have a total answer of 153,528 watts. And now I'm going to do that twice and make sure I get the same answer. And yeah, I get the same exact answer, 153,528 watts. So I know that that is everything added together, but I still need to do my demand factor. Okay, so I'm just going to write down a little mental note right now, demand factor. Now I'm going to open up my book and find that demand factor. I'm going to go to table 220.84, and I see that 3 to 5 units has a 45% demand factor. So we're going to take our 153,528 watts, and we're going to multiply that by 0.45, or in other words, 45%. And from here, we're going to get 69,087.6. Okay, and now it's good to know that in any other point of our load calculation, we're technically not actually supposed to be rounding up. We might want to, but we're actually going to get further away from the actual answer. The only time that the code tells us to round up is if we go back to Article 220.5 subsection B, is when it says fractions of an ampere. The codebook tells us to round to the whole ampere, which uses the decimal fraction that is smaller than 0.5 drops. So in other words, it's just like we're used to rounding up normally. If we have a number that's over 0.5, then we're going to round up. 0.5 or less is rounded down, but that's only for amps. Here we are still dealing with watts, so technically the book does not tell us to actually round anything yet. I know it seems kind of ridiculous, but technically we're not supposed to round anything yet. Okay, so I'm going to keep that number how it is. But we do have our demand factors already. So from there, what we can do is divide by the 240 to get the amps. Of course, that's 240 volts. This is going to give us 287.865. Now, this is in amps. So from here, this is where we are told that we're supposed to round up. We see we have 0.8. So obviously, that's above 0.5. So we're going to round this up from 287 to 288. So it didn't really make much of a difference that we chose to do that after, but we followed what the book told us, so we got the most accurate answer as possible. But we need to remember that this is probably not our final answer for amps, and looking at 288 amps, I can definitely tell that this is not a standard size for a breaker. So we want to find the standard size for the breaker, and that's going to be our overcurrent protection device. We're going to want to go to table 240.6a, and we're going to look for our number that we just got, 288 amps. In the table, we see 250 and 300. We see it's in the middle of 250 and 300, and we know that if it's in the middle of two numbers, and the next number is 800 amps or less, then we're actually going to round up. So in this case, in the middle of 250 and 300, here at 288, we're going to round that up to 300 amps, and that is going to be the size for our overcurrent protection device. Now I'm going to box that because I like to box my final answer, and now we can see that I have the 300 amp overcurrent protection device along with the 69,087.6 watts, which is the total demanded load for this duplex dwelling. Now from here, in a more real-life scenario, we might want to know what size of wire to use with this service. From here, we want to go to table 310.12, where we see the single-phase dwellings, and we see the sizes for our services and feeders. On the left-hand side of this column, we see in amps the rating for our service or feeder. we're working with a service, a 300 amp service. So we see 300 amp here on the left side, and we see that with that we have 250 copper and 350 aluminum. Of course, this means KC mil, but they're just telling us 250 and 350, so I'm just going to write it down as they show. And that is 250 copper or 250 Cu and 350 aluminum or 350 Al. Now I also have the size of wires that I can use with this service. Sorry if I didn't draw that the neatest. Maybe it's a little better now. I'm kind of running out of room. You get the point. I said what it was. Okay, and that's past what you need to know because the question was just asking us what was the overcurrent protection device, and we solved that, and we even took it a step further. Okay, and that's it. You can see it's actually pretty simple. There's not a bunch of demand factors like in the standard method, and it's pretty straightforward here using the optional method for the duplex and also the multifamily. The single family was a little weird because we had to add everything together and then disclude the heat or the AC, and then we had specific demand factors there in Article 220.82, and then we had to add back our heat or AC, whichever one was bigger, after that. Okay, so that was a little bit weird. If you need a refresher, of course, you can check out that video. I have a video actually explaining that. But we're done. It's finished. It's kind of funny that as we move along this load calculation series, it's actually getting a little bit simpler here with the optional method. And this is the last video for the residential load calculations. We did single family dwellings, duplex, and multifamily for both standard and optional. I have videos for all that with explanations and practice questions in each one. And now from here, we're going to move on to commercial load calculations if that interests you or if you need to learn about that. Okay, so be sure to check out those videos. If you enjoyed this video and you got something out of it, give it a thumbs up, share it with someone who you think will get something out of it, and to keep seeing the videos that I'm going to be releasing, make sure that you subscribe. If you have any questions, feel free to leave that in the comments. I check this account regularly, so I will see it and I'll answer it to the best of my ability, or maybe point you somewhere else where you can find the answer yourself. And I'm not just looking for nice comments, so if there's anything you think I could fix, let me know. You might say, oh, I need better lighting or something, and I would just say, okay, well, I will have that as soon as I have a better sort of recording studio. This is the best I have at the moment, but I am thinking about that. But if anyone has any other ideas or criticisms to tell me that could make my videos more quality, I would love to hear that, because that is only going to help me improve these videos and will help other people learn from the videos as well. So until next time, take care and goodbye.